So we talked about this yesterday. We talked about prisms and pyramids. We're all covered. Everybody was like, yeah, I got it. I'm in. No problem. We move along to taking what we already know, the fact that both of these shapes are just made up of two-dimensional shapes that we can already work with. As a matter of fact, they're shapes that we've been working with since the 5th grade. Once we take them from being single things and flat, putting them together, I build prisms and pyramids. Okay? What we are concerned about in this section of the course is the surface area, which is the exposed area of a solid. Now, does everyone agree my hand is solid? Everyone agree?
Yeah, I guess so.
Now, if I were to take my hand and dip it into a bucket of paint, where would the paint be?
On the outside.
All over the surface area of my hand, yes?
Yes.
Everybody watching?
Yes.
Now, I'm going to do something different with my hand. Then I'm going to dip my hand in paint. You are going to tell me if there will be more or less surface area. Is everybody ready?
It says less.
Why?
In there.
Because no paint can get in there. Everyone agree?
Yeah.
Okay?
Less, more.
Less again.
More
Why? More less. Why? Because now all this can't get paint and in there can't get paint. Does everybody understand surface area? All right. If I have a box without a lid, what is the surface area? Inside of the box and outside of the box. If it has a lid, what is it?
The outside of the box.
Just the outside of the box. Everybody understand?
Think outside the box.
No. All right, is everybody cool? All right. Next thing we're going to do is we're going to do exactly what this says. We're going to draw and calculate the surface area of a cereal box. Well, we all know what a cereal box looks like.
Is it open or closed?
It has a rectangle out there where the cereal is named. We're going to name it Matty-O's because that's my name and I'm in charge. And Cheerios sounds awesome. Now, that which I have drawn there is only one side of the cereal box, yes?
Sure.
That's the front. There is also the top,
Is it open?
and there is also the side. This is a brand new cereal box.
They must not like it.
Now, notice I've put no dimensions on here, yes? Right? Everyone agrees. Where would you put the dimensions? Where would you put, for example, the 8? Would it be horizontal, vertical, or the diagonal one? You would say that was the 8. Why? Because it's the shortest distance, right? We've all seen a box of cereal, right? Okay. Where would you put the 24? Horizontal or vertical? Horizontal. 24. And the vertical would be right there. Would everyone agree?
Yeah.
Excellent. Now, everybody can see where to put the numbers, yes? Now I want you to name these sides. What would you call this side? What are your options? You could call it what? Base? What else?
Width.
Width? What else? Length? What else?
Any letter.
Any letter?
A, B, C, D, E, F.
Okay. Let me ask you this then. How would you compare this distance, if you were to give it a name, length, width, something like that? What would you call that?
Height.
Height. Why, Ash? Because it's vertical. You stand the cereal box up, right? My shelf is too small. I can't stand the cereal box up. I have to tip it over. Now what's the height? My cereal boxes are in my cupboard this way.
That's weird.
Now what's the height? But you told me height is vertical. So wouldn't this be the height?
Yeah.
What was that? Of course it doesn't matter. Why doesn't it matter?
Because it told us it doesn't matter.
Because they're only letters. It only matters
look, it's my
Oh,
favorite
look at
teacher.
you.
Oh, it's my favorite teacher.
Thank you. Hey, I'm right here.
And you didn't even say your favorite math teacher because he's sitting right here.
Bye, Mr. Keeley. Why can't you be my math teacher?
Because you're going to be stuck in grade 10 now for a while.
Thanks for their confidence, Mr. Keeley.
All right. They're only letters, right? It doesn't matter how I stand it up because we're finding area, right? And area is always a multiply, yes?
Yeah.
And does order matter in multiply? Is 5 times 2 the same as 2 times 5?
Yes.
Yes. So it doesn't matter what we call these, right? Now you guys are smart kids. You recognize that this is what shape? A rectangle. Okay. So there's a green rectangle in my cereal box, isn't there? How many of them are there?
2.
Why?
Front and back.
Because there's one on the front and one on the back. What shape's that? A rectangle. How many of them are there? 2. Why? Left and right. Could that be the top and bottom?
Yeah.
Could that be the front and back? Just depends on how I put it in the cupboard, right? Times 2. And what's that shape? It's not a square.
It's a rectangle, dude.
It's a rectangle. And how many of them are there?
There's 2.
Okay. So how do I find the area of rectangles?
3 times the size.
What do I do to find the area of a rectangle? Length times width. So LW. But there's 2 of them. So what is the value for the green? It's 24 by what? 24 by 40 by how many? 2. What's the yellow? 40 by 8 times what? 2. What's the blue? 24 by 8 times 2. Now, you guys, that's what we did, yes? That's a lot of math, right? So the math guys in the past made us formulas for these things so we deal with them. The math guys say the formula for this, you notice these are all multiplied by 2, right? So isn't it the same thing to say 24 times 40 plus 40 times 8 plus 24 times 8 all times 2?
Yeah.
That's the formula. Now, the math guys that made these up don't like leaving these as letters, so leaving them as numbers. So they give them letters so it works all the time. So they will say, for example, that's W. They would probably say that's L, that's W, and that's H. And then they would write a formula. The surface area is 2 WH plus HL plus LW. Notice that each one of them multiplies with each other. And then all you do is punch it into your calculator.
Incubator.
Now, why centimeters squared? Why did I go through all this mess? Because the formula works when?
You know all the
Every time when you know all the stuff and all the stuff is there, right? If there's no lid on this box,
Oh.
is the blue going to be times 2?
No.
No, it's only going to be times 1, right?
Yeah.
Everybody understand what I'm saying? That's why I'm showing you how we build the formula, how we get the formula, and then the formula works in math class, but in real life, does the formula always work?
No.
Or do you need to use the whole formula?
No.
If I was going to paint this room, if I said go paint this room, painting would be surface area, wouldn't it?
Yeah.
This room, forget the slanty roof. Pretend the roof goes right around the top. and pretend that's not there. Just pretend it's a regular room. It's a prism, isn't it? If I was going to paint it, it would be the surface area, wouldn't it?
Yeah.
And the surface area is right there, isn't it? Is it? If you paint a room, do you paint the floor? No.
Unless you really want to.
Do you paint the ceiling? Maybe. I have white ceilings in my house, but maybe you don't.
Maybe you want
So knowing the formula is one thing. Using the formula is something totally different. Does everybody understand? That's why I'm going through this step of showing you why the formula works, instead of just saying, here's the formula. Everybody cool?
Yep.
All right, next question. Why is that squared? That's a three-dimensional figure. It must have 3 dimensions. Why is it only squared? Corey?
Because you're not counting from the depth, you're only counting for what's being covered.
I understand what you're saying. We're not counting anything inside. All I'm counting are the 6 rectangles on the outside. And a rectangle only has 2 dimensions. Everybody good? All right. Turn the page over, please. This is a misprint. I copied and pasted this from the honors book. You guys need to make some changes to this. You are getting rid of rectangular. So cross that right out. And you are getting rid of the 48. And this is supposed to say slant height. Sorry about that. Now, some of those words there, even though you probably did some of this in grade 9, some of this is probably a little bit, I don't quite remember what you're talking about, Myers, so we're going to work with it here. So, if it's not a rectangle pyramid, what is the bottom? It's got to be a square because I said it's got a base dimension of 32. So I've only given you one dimension, so it has to be square, doesn't it? Because a square has all sides the same. So we know that the bottom of this pyramid is going to be 32 by 32, correct?
Yeah.
Now how do I make it a pyramid? That shape's got to repeat up to nothing, yeah? So it's going to repeat up till it disappears, agreed? That's how we build it. But now I want the surface area, which is what? What? The surface area is the outside, yeah? What is making up the outside?
Bunch of triangles.
How many triangles?
4.
So there's 4 triangles. And what's the bottom?
Square.
1 square. Everyone agree? So if I want the surface area, I must need the area of 4 triangles and a square, yes? Are all those triangles the same?
Yeah.
Yep, because they all start at the bottom. They're all the same. So I have 4. What is the formula for the area of a triangle? Who can remember?
Base times height divided by 2.
4 base times height divided by 2. Right? Plus, what's the area of a square?
Base of height.
Length times width, base times height. Except what's special about a square?
The base and the height are the same.
The base and the height are the same, and the length and the width are the same. So would we say length times width, or would we say some other letter squared? It wouldn't matter. So I could put LW here and remember that it's length times width, couldn't I? If the square goes up and down, regardless, you could say base and height, couldn't you? All right. So here it's going to be LW, but we're going to remember L and W are the same.
So those are times together.
All right. So now we got to talk about this because this is a mess. We talked about bases yesterday, didn't we?
Yeah.
Okay. Don't write down what I'm about to do. I just want to show you guys something. What's the base of that triangle?
4.
What's the height?
6.
So the area of that triangle would be 4 times 6 divided by 2, correct? Okay. It would be 12. Now what's the base? Why? It's on the top. Because it doesn't matter. You guys got to recognize that, yes? Okay. Let me ask you this then. I lie. What's the base of that triangle? Don't go to your calculator, Louis. Look at it for a second. Why is it 4? Because what did I do?
You rotated it.
I rotated it. Couldn't it stand straight up
Yeah, good.
with 4 and 6? Why did Louis jump to his calculator?
Pythagoras.
Because he was going to do Pythagoras right here. Which would give him this distance, yes? That would be the square root of 6 squared plus 4 squared, yeah?
Whoa.
Which would be the square root of 52, right? Which would mean this is the square root of 52. Louis, did that give you the height anywhere? No. See what I mean? Pay attention to what's happening to the triangles. Because bases and heights only exist when? When you're talking about them, in your case. Why do we say base and height? So we can write a formula. It's not the spot it is on the triangle. Does everybody get what I'm saying?
Yes.
Okay. So we've got 4 base times height. Well, the way we've drawn our pyramid, is it safe to call this the base? Both the bottom and the base of the triangle. Is it? Okay. Now, the slant height. What's a slant? Right? What's a height? Straight up and down. What have I given you here? Slant height. So I have told you that if you were to walk up the side of this pyramid, it would be 65, right? That might be the side of the pyramid is the slant height, but what is it for the triangle? Yeah, you do. Because isn't that triangle that I just drew that?
Yeah.
And it's 32 on the bottom, yeah?
Yeah.
And up the side of the pyramid is? So what is that slant height? Slant height of the pyramid, but what is it for the triangle? It's the height, isn't it? Is everybody comfortable with that? Okay. You have to remember, point 1, height is not slant height. That needs to be reminded. All right, so now let's have a look at what we're building here. I got a 4 up there and I got a 2 down there. What's going to happen to that 4 and that 2? It's going to reduce to what, Aisha? 2. So I'm going to have 2BH, right? Except it's not H on the pyramid. What is it on the pyramid? Slant height. So I shouldn't put H there because height isn't slant height. So what letter do you think they use? S, absolutely. So they, when they're making the formulas, they go 2BS. And S is your slant height. I know, I do it on purpose. Everybody cool? Now, LW. We know that they're the same. And we have already given this a letter, haven't we? What letter did we give it? B, because we called it the base of the triangle, yes? So should we keep it as B? Yep. And it's B times B, which is B squared. That is how you find the formula of a square pyramid. I forgot the A. I just wrote pyramid. That's okay. Spelling doesn't count. It's the 21st century.
And why do we still take English?
Because English has nothing to do with spelling.
Well, she says there's spelling.
Spelling is important.
You just said it's the 21st century. It's not important.
Yeah, I'm saying it ironically because nobody cares about things like spelling anymore.
True.
Because you people will say BRB in a text.
You're the GGG.
I know.
Yeah.
What is funnier, I think, to me is that you people think you guys invented that. I know that.
Yeah.
25 years ago, 30 years ago, we were saying that when the internet was all text. There were no pictures. It was lame.
We also used to take selfies with big cameras that you just turn around.
Yes. All right. So everyone cool with that? Now, this is doable because we have the slant height. The other warning you need over here in your warning section, if you need slant height, you must do some other math. What math would that be? If I told you, and you don't need to write this down, if I took away that word slant, and I told you the height was 65, where is the height of a pyramid? Right down the middle, right? Doesn't give me a slant height, does it? Unless I do this. What did I just draw?
Triangle.
What kind of triangle?
A red triangle.
A right triangle. What can we use to work with right triangles to find the side we don't know? Now you need Pythagoras. Okay? You must do Pythagoras. And Pythagoras is a squared plus b squared equals c squared. Now, in this equation, c squared is your slant height. B is still your base, and A is your pyramid height. That is the one you would use when dealing with pyramids. Everybody cool? Everybody cool? Okay. So now we've got this right here. We're going to fill it in. To, what's B? What's B? 32. What's S?
65.
65. Plus, what's B? 32. And what's happening to B? Squared. Everyone punch that into their calculator and see if they get the right answer. Because a lot of times people write it down right, punch in the wrong number, get an insanely crazy number that couldn't possibly be right, and still write it down. And their answer to me is, my calculator said so. Damn right. You got to punch in the right stuff to make your calculator work. Who has an answer for me?
Not yet. Hold on.
I heard someone say 5,000.
5,284.
5,284?
I got 5,100.
I got 184. Feet squared. Everybody cool?
Yeah.
Now, let me ask you this. Real life or math problem? Math problem. In real life, is that part considered part of the surface area of a pyramid? Most likely not, because it would be the floor, right? What about that pyramid I showed you guys in Paris that was upside down? Is that part of that surface area?
I don't know. Except that.
If you had to clean that glass pyramid, would you have to clean that part of it?
No. mounted from the top in Paris. The pyramid was mounted at
I
the
know.
top.
I know.
So we have to clean that because it's mounted to the roof.
Is it?
Yeah.
And you see right through it. It's clear.
Well, I don't know.
I know you wouldn't know, but I'm just saying, right?
So you'd have to go outside the building, clean it from the
Yes.
Oh, that doesn't count.
I'm just saying you have to be aware of the situation, Aaron. Right? Everybody good?
Yeah. Now
All right. Let's go on to the next question.
Oh, there's another one.
There's 4. We're at 3. We're halfway there.
We're halfway there.
Yes, we are indeed living on a prayer, Eric. Tommy and Tina.
Yeah.
Yeah.
Tina.
Okay. I'm fine with that. Tina's the one that does all the work anyway.
Sounds about right.
Yeah. All right. I got a cone now, yeah? What's a cone look like?
You put ice cream in it.
Exactly. How's it start?
Circle.
Triangle.
Starts with a circle,
A circle, base with a triangle.
and it goes up like that, yeah?
Circle.
There's the dots. So we know that it's a circle, and Louis says it's a triangle. Is it?
Not. I don't know.
Well, let's find out, because we should be able to build it, right?
Oh, you're right. Look at smart man go.
Triangle, yes?
Yeah.
Make it a cone. Did it work?
No.
Why? It went down, didn't it? What should a cone be? Straight bottom, yeah? So it's not quite a triangle.
It's half triangle. Because it's
Half a triangle's still a triangle, dude. So it's not quite a triangle. What else could it be? A square? There's a square. Can you make it a cone? Okay, so it's not a square.
I don't know what it is, man.
It's close. It's related to a cylinder.
I think she knows.
Oh, Dana.
It's like, if you cut like a tennis ball in half and you only take like, you have like a straight line top and top of it.
There you go. It's a section of a circle, isn't it?
Oh, that's right.
Because it's got to get all the way around down here. So it can't be a straight line. Everybody with me? All right. So it's a section of a circle and a circle. How do I find the area of a circle?
Something with diameter and circumference and a bunch of stuff.
Well, it's actually only 2 things.
Radius squared.
And pi.
I like pie.
So that is pi r squared, yes? And then we got to add something. Now, we're aware that this is part of a circle, yes? So if we're ever doing the area of a circle, we must need pi and we must need r, correct? Everyone agree? Okay. Now, the other part of this was what fooled mathematicians back in the day. They're like, well, it's not a whole circle, so it can't be pi r squared,
Can't you just divide it by 4?
but it's not a quarter. That's the other thing they did. They said, well, maybe it's divided by 4. But it wasn't. So what they did was they actually did 1 million experiments, and they found out after doing 1 million experiments that if you multiplied the slant height, because they knew from pyramids that slant heights were important, they knew that cones are related to pyramids, they found out that if they multiplied the slant height here, they got the right answer. They built the formula from models. Everybody cool? So now, all we got to do is fill in what we know. Surface area is pi. Do I know the radius?
Yeah, it's 15.
It's 15 squared
15.
plus pi times the radius, 15. Do I know the slant height?
No, you know the height.
I only know the height. What do we have to do if we need a slant height and we know the height? We got to do Pythagoras. What do I need to do Pythagoras? A triangle. Where does the triangle go? Right down the middle. to the center of the circle and out to the side, yes? So there's the triangle with which I am working. What is this side?
That's your height.
Which is
22.
22. What is this side?
15.
15. How do I find the slant height?
You do the square thing with the square.
Right. I do 22 squared plus 15 squared. And then what do I have to do to that whole answer when I have it? I gotta square root it. So many kids forget the square root. They tell me that if I walk 15 steps that way and 22 steps that way, I'm 600 steps away from where I started. Because they forget to square root. And what does that give me? 26.6. 1 decimal's fine for what we're going to do right now. So now we have a slant height, yes?
Yes, we do.
And where do we write that?
Beside the 15.
26.6. Is everybody good? Now, previous to this year, what did you do with that and that? Think back to the first time you ever heard of pi. What did your teacher tell you to do?
Put it in the oven.
Press the button. That's what we do on our calculator, right? Okay. We don't make it 3.14. We push the button on our calculator, and then our calculator does the thinking for us, yes? And it gives us a big, hideous number with lots of decimals, and then we round it off, right? So if we were going to punch that all into our calculator, we'd end up with a number. It's going to be something like 2,000.
1,000.
Yeah, great. You punch in your calculator, you're going to get a number, yes? Right? Okay. Whatever your calculator gives you, that is the real life number. Because in real life, you need to have a number, don't you? You can't go to the store and say, hey man, I need 300 pi of this. Can you? No, you need a number. In math class, however, we're going to do something slightly different. After grade 10, pi stays as pi in math class. You're going to leave it as pi. How does that work? You pretend it's like a variable. Everybody understand? So what's 15 squared? If you don't have it memorized, you're going to do it on your calculator. You're going to find it's 225, right? So you would have 225 pi plus. Pi is going to stay there. So what do I do with 15 and 26.6? Multiply them together, and what do I get? 399.4 or something, right? 399 exactly? Okay. 399 pi. Now, since that's 399 pi and that's 225 pi, what can I do with those two numbers? Add them, and I get 624 pi. In math class, after grade 10, this is what we are looking for. Because pi isn't an exact number, yes? It goes on forever. Everybody cool? For me, I don't care. Whichever way you're comfortable with, do that. If you want to leave it as pi, leave it as pi. If you want to get to the 1961.7, whatever it is, do that. I don't care. But I want to introduce you to the fact that as you go further in math class, you are less and less and less and less to the point where you never use pi as a number. You just leave it as the letter. Everybody cool? I don't care what you do, either one. I personally like to leave it as pi because it's tidier. Everybody with me? But again, I can't go to Home Depot and say, hey man, I need enough paint to cover 624 pi centimeters squared.
I think he would look at you.
He'd say, you're an idiot. My number in softball is pi. Because I'm a math teacher. And it's actually on the back, the letter pi.
10.
When my buddy was ordering the uniforms, he's like, okay, what numbers do you want? And he's like, 7, 32, 97, pi. What? Pi. You mean 3.14? No, pi. Guy wants the symbol for pi. And they're like, whatever. No, that's what he wants. Okay. Then when he fills out the roster and he puts everybody's number, John Smith, 8. Paul Jones, 12. Matt Myers, 3.14. It's funny.
Yes, 3.14 of a man.
Yeah, it takes 3 and a bit men to equal me. All right.
Don't you mean it takes 3.14 Myers to make a man?
No, that's not what he said.
That's what I meant.
But that's not what you said.
That's what you meant.
3.14 of a man.
Ah.
Aha.
All right. Let us do this last question, then I'm shutting up and letting you guys work. So you have like over half an hour to do your homework. Huh? You have 25 minutes to do your homework. All right. Calculate surface area of pop can. What shape's pop can?
Cylinder.
Cylinder. What shape's the cylinder? Circle on the top, circle on the bottom, and what's in the middle?
A bunch of circles. Stack of
No.
Rectangle.
Rectangle, right? So we know that a cylinder is 2 circles plus a rectangle, yeah? Right? What's the area of a circle? Pi r squared, and there's 2 of them, 2 pi r squared. Plus, a rectangle should be what? Length times width. We also call it base times height, right? Everybody cool? Now, on a cylinder, right now, what would you say the base of this is?
Silver part.
The silver part, the circle. Is it the base in the bottom? Is it the base in the base shape? Or is it both?
Whoa.
It's both, because it's a circle that goes up and it's on the bottom, yes?
Yes.
If I turn it this way, is it still the base shape?
Yes.
Yes, but it's no longer the base, is it?
No.
Everybody cool? Okay. What would you call that measurement of my mug?
Height.
Height. Why?
Because it's the up and down.
Because it's the up and down one, idiot. That's what height is. Now what's the height?
The up and
The
down.
up and down one. But wait a minute, that's the diameter.
It's the same thing.
This is still the height,
Why?
right?
Yeah.
Right?
Yeah.
Everybody with me? What if I turn it that way? What's the height? Still that side in the formula. But in reality, the height would be this imaginary line from there to the bottom, wouldn't it? Okay, cool. So you guys want to call that h. So if we're calling that h for height, we're going to be using this, aren't we? So we know we got to multiply by the height. Now, how then do I get... Come on. I know I need the height, but now I need the base. The base of a cylinder is what?
Bottom.
It's that, isn't it?
Yeah.
What measurement is that?
I mean the diameter.
It's the perimeter of a circle, which is what? Circumference. What's the circumference of a circle? Circumference equals pi d, right?
Pi.
Now, if you were writing a formula, would you want as few letters in it or as many letters in it as you could get?
Few.
You want as few as you could get, right? You know you've already using an R there, yeah?
Yes.
Does R and D have a relationship?
Yes.
What is it?
R is half a D.
2 R's equals D, right?
Yeah.
So what could I put there instead of D? 2R. So the circumference is the same as 2 pi R's, isn't it?
Yeah.
2 R's with a pi. I need that circumference here, don't I? 2 pi's with an R. And that's how they built that formula. Everybody cool?
Yes.
And all we do is we fill in the numbers. 2 pi, what's my R?
Your R is 5.
R is 5. Good, I didn't fool you. Because I gave you a diameter.
Trying to be sneaky.
I was trying to be sneaky, but not really sneaky, right?
Seven.
Just a little sneaky.
Little sneaky.
Plus 2 pi 5 20. Now, last year, you punch all that into your calculator, right? And you get a number. And that number's ugly because it's got a bunch of decimals. From here on out, I would prefer it, but you don't have to. What's 5 squared?
25.
What's 25 times 2?
50.
50 pi.
50 pi.
What's 5 times 20?
100.
Times 2?
200.
200 pi. What's 50 plus 200?
250 pi.
250 pi. And you can do it in your head and save a whole lot of time.
Wow.
If you're uncomfortable with that, what are you going to do with that? Or if I say I need a real world number, on your calculator, you're going to do 250 times the pi button. And you're going to get something around 800. 785.3. Pretty darn close to 800. Everybody cool?
Yeah.
All right.
Made a lot of sense.
Now, you guys have homeroom at, class goes till 2:29. You're supposed to have homeroom the last 5 minutes for 2:24, which means you got 27 minutes right now. I want you to finish pages 30 to 32. Now, I want to take a moment here. There's a couple of things that don't show up in your drawing. One, letter B there is missing something. That is 90 degrees. So draw that in. It doesn't show up in the photocopying. Please notice here. What do you have? You actually have
Square and rectangle.
2 prisms. You did this in grade 9. I haven't reminded you of how to do it. I want to see what happens when you try this. Okay?
I'm trying to confuzzle us.
I'm not trying to confuzzle you. I want to see if you remember how to do those. Page over. Notice anywhere that you have right angles. Check for them. Yeah? Everybody cool? Okay. And I think that's... Oh, in the word problem, look very, very closely at the words.
Gallon. I don't like you.
What do you see there? Gallon. What do you see there? Feet. What do you see there?
Meters.
Oh, you dink. Ha ha ha.
Exactly what I'm thinking.
All right? Go.
This sounds like work for
We'll be marking this tomorrow.
Sounds good.